In this video, we're going to be taking a look at solving area equations, and you'll need to turn your Go Math book to page 383, get out your math journal, and a pencil. So the essential question we're going to be looking at today is how do you use equations to solve problems about area of rectangles, parallelograms, trapezoids, and triangles. Now in previous lessons, we have already looked at how you find area of these different types of shapes. Okay, so let's take a look at problem solving using the area of a triangle. Recall that the formula for the area of a triangle is area equals 1/2 times base times the height. You can also use the formula to find dimensions if you know the area of one dimension. So let's take a look at example number 1. It says the Hudson High School wrestling team just won the state tournament and has been awarded a triangular pennant to hang on the wall in the school gymnasium. The base of the pennant is 1.5 feet long. It has an area of 2 and 2,500 square feet. What is the height of the pennant? Now, what we need to figure out is just the height. So we know the area. So first of all, area equals 1/2 times base times the height. We need to write the formula out. Now we're going to use the formula to write an equation. So we have 2 and 2,500 equals 1/2 times 1.5 times the height. Now we do not know the height. That's what we're trying to figure out. Now, first of all, what we need to do is we need to multiply the 1/2 times what we know. That's 1.5. Okay, so now we have 2 and 2,500 equals 7,500 times our variable or times the height. We don't know that yet. So just like algebraic equations, what we need to do, so since this is multiplication, 7,500 times h, we're going to divide 7,500 on both sides of the equation. So 7,500 divided by 7,500, you can see that cancels it out. 2 and 2,500 divided by 7,500 equals 3. So we know the height of the pennant is 3 feet. Okay, so you can see those different steps that we use to find the unknown height. Now we can plug that in. So we can do area equals 1/2 times the base, which is 1.5, times the height, which is 3. So we can see that that would equal that 2 and 2,500 for the area. Now let's do one together. It says Renee is sewing a quilt whose pattern contains right triangles. Each quilt piece has a height of 6 inches and the area is 24 inches squared. So first of all, what we will do, and let's do this together. You can do this in your math journal. We know that area equals 1/2 times the base times the height. We know the area for this is 24 inches squared. So 24 inches equals 1/2. We know that the height is 6 inches. So the base times the height, which is 6 inches here. Okay, so my first step is we're going to take that 24, rewrite it again. We're going to multiply 1/2 times 6. It's going to give me 3. So 3 times the base now. Okay, so what I'm going to do is I'm going to divide 3 on the right-hand side of my equation and also 3 on the left-hand side. So we know we've eliminated our 3 on the right-hand side. And we can bring down our b. And then we have 24 divided by 3. Once again, why did I divide? Because that's multiplication. We're dealing with multiplication. If it was division, we would multiply. Do the inverse operation. 24 divided by 3 gives me 8. Okay, so how long is the base of each quilt piece? We can see the base is 8 inches. So now we're going to take a look at this, writing an equation using the area of a trapezoid. And you can use a formula for area of a trapezoid to write an equation to solve a problem. So we have example 2. It says a gardener in the shape I'm sorry, a garden in the shape, kind of be odd to have a gardener in the shape of a trapezoid, but a garden in the shape of trapezoid you can have, has an area of 44 and 4/10 square meters. One base is 4 and 3/10 meters long, the other base is 10.5 meters long. The height of the trapezoid is the width of the garden. How wide is the garden? So we have an unknown measurement that we need to figure out. We know a lot of different things, so we know the formula is area equals 1/2 times the height times base 1 plus base 2. Now we're going to use the formula to write the equation. 44 and 4/10 equals 1/2 times the height times base 1 plus base 2, 4 and 3/10 plus 10 and 5/10. So we add 10 and 5/10 and 4 and 3/10 together. That's going to give us 14 and 8/10. Now we have 44 and 4/10 equals 1/2 times the height times 4 and 8/10. Now what we need to do is we need to take our known measurements, which is 1/2 times 14 and 8/10, multiply that together. That's going to give me 7 and 4/10. So now we have 44 and 4/10 equals 7 and 4/10 times the height. Now since this is multiplication, we're going to divide by 7 and 4/10 on each side. 7 and 4/10 eliminates and just has the h, or the height, alone. And 44 and 4/10 divided by 7 and 4/10 gives us 6. So we can see that the garden is 6 meters wide. Okay, now let's take a look at that reflect question. It says explain why the first step after substituting is addition. We know by order of operations you perform operations inside parentheses first. Okay, so that's important to know. Now let's take a look at number 3. We'll do this together. It says a cross section of a water bin is shaped like a trapezoid. The bases of the trapezoid are 18 feet long and 8 feet long. It has an area of 52 square feet. What is the height of the cross section? So we're going to first of all write down our formula. So we know that area equals 1/2 times the height times base 1 plus base 2. Now that you've written the formula, we can plug in what we know. So we already know that the area is 52 square feet. But that's not what we're trying to find. We're trying to find the height. 52 square feet equals 1/2 times the height times base 1, which is 18, plus base 2, which gives us 8. Now our next step is adding what's in the parentheses. 18 and 8 gives us 26. So now we'll have 52 equals 1/2 times the height times 26. Now what we'll need to do, multiply 1/2 times the known measurement. We can't multiply 1/2 times the height yet. We don't know that. So 1/2 times the known measurement will give us 13. So now we have 52 equals h times 13. Now that we have everything, all the steps that we can do, and we just need to find h, what we'll do is we'll divide by 13 on both sides, just like we would with an algebraic equation. So we have that 13 is eliminated, so now we just have our h for the height. 13 into 52 goes 4 times. So we can see that the height of this cross section here is 4 feet. So again, why did I use division? I was using division because it's the inverse operation of multiplication. So let's take a look at solving multi-step problems. It says you can write and solve an equation that represents real-world problems related to relationships in geometry. Okay, so the problem is John and Mary are using rolls of fabric to make rectangular stage curtain for their class play. The rectangular piece of fabric on each roll measures 2.5 feet by 15 feet. If the area of the curtain is 200 square feet, what is the least number of rolls they need? So what I want you to do is take a look at all the different steps. It says analyze the information. So it's important to rewrite the question as a statement. You want to find the least number of rolls of fabric needed to cover an area of 200 feet squared. So that just kind of helps you focus in on what you need to do. You also want to list the important information. Each roll of fabric is 2.5 foot by 15 foot rectangle, and the area of the curtain is 200 square feet. Then you want to formulate a plan. Write an equation to find the area of each roll of fabric. Use the area of the curtain and the area of each roll to write an equation to find the least number of rolls. So write an equation to find the area, and then we want to solve it. Write an equation to find the area of each roll of fabric. So we know the area equals length times width. Area equals the length, which is 15, times the width, which is 2.5, giving us an area of 37.5 feet squared. Then we want to write an equation to find the least number of rolls. So n equals 200 divided by 37.5, and then we have the answer 5 1/3. So it says that the problem asks us for the least number of rolls needed. So since 5 rolls will not be enough, they will need 6 rolls to make the curtain. So John and Mary will need 6 rolls of fabric to make the curtain. So you can see that process and how each step follows another one, and it's important to just think through them and make sure you're not missing any information or anything like that. Now you can justify and evaluate. The area of each roll is about 38 feet squared. So since 38 feet squared times 6 equals 228, the answer is a reasonable answer. Okay, let's take a look at number 4. We'll do this together. It says a parallelogram shaped field in a park needs sod. So the parallelogram has a base of 21.5 meters and a height of 18 meters. The sod is sold in pallets of 50 square meters. How many pallets of sod are needed to fill the field? So we know that the area, or the formula for a parallelogram, area equals base times the height. Okay, so we know that area equals 21.5 times 18. Okay, and then we can multiply 21.5 times 18. And you can see we get 387. Okay, so that is the area of the parallelogram. Okay, now we're not done yet though. So area equals 387. Okay, and I'm going to move my calculator here. So now we need to figure out how many pallets of sod are needed. So we can see P equals 387 divided by 50. Okay, so we can take 387 and we're going to divide that by 50. Why 50? Because the sod is sold in pallets of 50 square meters. So 387, divide that by 50 is going to give me 7.74. Now we cannot have 7.74 because that will not fill the field, or we can't have 7, okay, and you can't buy 74 hundredths of one. So how many pallets are needed to fill the field? You can have 8 pallets. You can write that down. Now what I would like you to do is take a look at number 1 and work on that independently, and you can work on that now. Okay, you can see the answer for this. Write and solve an equation to find the height of the base of the triangle. Okay, so you can see 16 inches would be the length of the base of the triangle. I think I might have said height, the length of the base. Okay, let's take a look at number 2. I want you to work on that independently, and you can work on that now. Okay, you can see the answer for number 2, 28 centimeters, and you can see the equation that's written right there. Now I'd like you to work on number 3 independently, and you can work on that now. Okay, you can see the answer for number 3. You can see all the different steps, and Taylor will need 4 gallons of paint. So let's wrap up the video. Let's take a look at the essential question. How do you use equations to solve problems about area of rectangles, parallelograms, trapezoids, and triangles? So what you do is you use the formula for the area of the figure to write an equation, then solve the equation to find the missing dimensions of the area or the area of the figures. So this concludes the video on solving area equations. If you have any questions about this concept, please come and see me.